Hello friends, in this video we will learn how to solve any factor programs. The programs which we are going to cover in this video are all the programs which require you to find factors like prime number, perfect number, composite number, etc. These programs follow a similar pattern, so we will learn to solve them using a similar framework or template. I'm using Java language over here, but if you know C, C++, Python, you can continue watching as concept wise it is the same. So the first thing is that we will assume we have some number n for which we need to find factors. Now you could be asked to write main and take in the number from the user like using a scanner class. It is also possible that you are asked to implement program as a function where you get this number n as a parameter. So for our program, I will assume we have got n from any of these methods and I will showcase the code starting from this point. I am assuming you do know how to fit in the program in main or a function block. If you are still having any issues, you can view all the programs on our website. Coming back to finding the factors, a factor of a number is a number which divides into it exactly without leaving a remainder. How do we write a program to find the factor of a number? First, let's understand the logic which we will use. Let's say the number is 8. What we will do is that we will divide the number by all numbers from 1 to itself. Whenever the remainder is 0, those numbers are factors. Now we will write the program. We have our number n, which is 8 here. There are two parts here. First is we need to get numbers from 1 to n. For that we will set up a loop from 1 to number n, which will run n times. Here variable I will give us numbers which we will check if any of them is a factor. Now we need to check which of them gives us 0 remainder. We will use a if statement and inside it we will use a modulus operator or percent operator to get the remainder. If it is 0, means we have got a factor. In this program, we are just required to print the factors, so we will just write a system.out.println to print the factors. Now we will use this program to convert into a template to solve any of the factor programs. In all our programs, there will be some kind of initialization before the loop, then there will be some logic inside the if statement, and outside the if statement there will be some check block. We will use this template to solve all the remaining factor programs. Let's first see a simple program where we have to find if a number is prime number or not. A prime number is a number which is divisible by only 1 and itself, so it has only two factors, like 5 is divisible by only 1 and 5. So in the initialization, we will write count and initialize it to 0. In the logic section, if the condition is true, we will just increment the count. In the check condition, we will check if count is 2. If yes, then we print the number is prime, otherwise it is not. Now let's solve another program for composite number. A composite number is a number which has more than one factor excluding 1 and the number itself. Here, since we have to find the number of factors, in initialization we will have count initialized to 0. In the logic section, if we find a factor, then we will just increment the count. In the check section, we will check if count is greater than 3, as we need to discard 1 and the number itself, and after that the factor has to be greater than 1. So we are checking for greater than 3. This gives us our program for composite number. Now we will do another program, perfect number. A perfect number is a number which is equal to sum of its divisors or factors except itself. For example, 6 is equal to 1 plus 2 plus 3. Here important thing to note is they are asking us to ignore the number itself as factor. So we will make a slight change in the template so the number itself is not included in the calculation. We will run the loop till less than n only. Now in the initialization, since here we are asked to find sum, we will initialize the sum to 0. In logic section, if the number is a factor, we will just add it to the sum. In the check section, we will just compare the sum with the number. If it is equal, it is a perfect number, otherwise it is not. Now we will do a program for abandoned number. Here sum of factors is greater than the number itself. For example, 12 has factors of 1, 2, 3, 4 and 6, which if we add gives 16, which is greater than 12. Here in initialization, we will initialize the sum to 0. Here also we will run the loop till less than n, as program is not considering the number itself as the factor. In logic, we will just add the factor to sum. In check section, we will just check if sum is greater than n for it to be abandoned number. This is our program for abandoned number. Now we will do a program for deficient number. In this, the sum of factors is less than the numbers itself. For example, 21 has factors of 1, 3 and 7. If we sum them up, we get 11, which is less than 21. Here in initialization, we will initialize the sum to 0. Here also, we will run the loop till less than n, as program is not considering the number itself as divisor. In logic, we will just add the factor to sum. In check section, we will just check if sum is less than n for it to be deficient number. This is our program for deficient number. Next, we will do a program for pronic number. Pronic number is a number which is the product of two consecutive integers, that is, number of the form of n into n plus 1. For example, 56 is equal to 7 multiplied by 8, which are consecutive numbers. Here in initialization section, we will initialize fact to 0. In the logic section, once we have a factor, we just multiply it by the next number and check if it is same as the original number. If yes, we just set fact to that number. In check section, we will just check if fact is non-zero. If yes, it is a pronic number. If you want, you can print fact and fact plus 1 also over here. If it is 0, then it is not a pronic number. Hope you have understood these programs. They are also available on our website too for your reference. Thank you.